Hello guys, welcome back to the Signals and Systems lecture series. This is problem set 4 and in this video we'll be solving some questions based on Fourier transform from the book back of the book Signals and Systems by Alan V. Oppenheim, and also we'll see some gate questions later on. So let's get started. Going to the first question, determine the Fourier transform of e power minus 2t minus 1 mod t minus 1 using the analysis equation. Okay, this is a straightforward thing, right? So the analysis equation, we have x of j omega is equal to integral minus infinity to infinity x of t e power minus j omega t dt. So this is our analysis equation. So we also have the other equation, right? Which is the inverse Fourier transform equation. That is also called as the synthesis equation. So that is given by 1 over 2 pi integral minus infinity to infinity x of j omega e power j omega t d omega. So this is our synthesis equation. Okay, so now let us use the first equation. So our x of t is nothing but e power minus 2 mod t minus 1. Right? So our x of j omega is nothing but integral minus infinity to infinity e power minus 2 mod t minus 1 e power minus j omega t dt. So to evaluate this integral, we can divide the limits from minus infinity to 0. So in that here it is mod t minus 1. So we have to do it from minus infinity to 1, because for t less than 1, mod t minus 1 is equal to minus of t minus 1, correct? So this will become 2 into t minus 1. And we have e power minus j omega t dt plus integral from 1 to infinity. And we have e power minus 2 into t minus 1 e power minus j omega t dt. So why here it is minus? So for t greater than 1, we can say greater than equal to, doesn't matter. So mod t minus 1 is nothing but t minus 1 itself. Okay, so now we can solve these separately. So e power minus 2, we can take it out. Integral minus infinity to 1. E power 2 minus j omega into t dt. Correct? And here we have e power 2 integral 1 to infinity e power minus of 2 plus j omega, right, into t dt. So let us solve them. Minus 2, this will be e power 2 minus j omega into t by 2 minus j omega from minus infinity to 1 plus e power 2 e power minus of 2 plus j omega into t by minus of 2 plus j omega from 1 to infinity. So what is this going to be? E power minus 2. For 1 it is going to be e power 2 minus j omega, right, by 2 minus j omega. And for minus infinity it is anyway going to go to 0. So we have only this plus e2. And again here it is 0 minus of this 1, right, substituting 1. So this minus and that minus will cancel. So I will just get minus of 2 plus j omega by 2 plus j omega. So now minus 2 plus 2 will cancel. We will have e power minus j omega by 2 minus j omega. Plus here also my plus and minus cancels. We have e power minus j omega by 2 plus j omega. So e power minus j omega is common. So we have 1 by 2 minus j omega plus 1 by 2 plus j omega. So taking LCM, what will we get? We'll get 2 plus j omega plus 2 minus j omega, which is nothing but 4. By denominator, we'll just have the absolute value, which is 4 plus omega square. So this is our final answer. So this is nothing but 4 e power minus j omega by 4 plus omega square, right? So you can see why this minus j omega factor comes, because it is time shifted by -1, right? So we get the factor of minus j omega t naught, and t naught is equal to 1 that way. So what will be the Fourier transform of just e power mod t? This will be 4 by 4 plus omega square. So in general, if it is e power minus a mod t, what will it be? So if here we can see, right, we'll get 1 by a minus j omega plus 1 by a plus j omega. So when we cross multiply, we'll get 2a divided by a square plus omega square. So it will be 2a by a square plus omega square. Okay. So let us move on to the next question. Question 2. Consider the signal x of t equal to 0 for t less than minus half, t plus half for t between minus half and plus half, and 1 for t greater than half. Find a closed form expression for x of j omega. Okay. And the second part, they are asking what is the Fourier transform of g of t, which is given by x of t minus half. Okay. So first let us try to sketch x of t. Let's look how it looks. So x of t, we have minus half, this is t. So up to half it is 0, minus half it is 0, and at minus half it is t plus half. So it is 0 at minus half, and at half it goes to 1. So linearly it goes, and then it stays there, right? So it stays at 1. So now we need to find the Fourier transform of this x of t, which is given by x of j omega. So I will just take another signal x1 of t, which is a square pulse. So minus half to half. If you see the relation between these two, you can observe that this x of t is nothing but integral of x1 of t. So x of t is nothing but integral minus infinity to t x1 of t dt, right? So now we already know the Fourier transform of x1 of t. So if it is t1, we know that it is going to be 2 sine omega t1 by omega. Here t1 is nothing but half, right? So t1 equal to half. So x1 of j omega is nothing but 2 sine omega by 2 by omega. Okay. So now x of j omega in terms of x1 of j omega is nothing but it is x1 of j omega by j omega plus pi x1 of 0 delta of omega, right? So this part we can easily find. What is x1 of 0? So x1 of 0 is nothing but integral minus infinity to infinity x1 of t dt. So it is the dc part of this x1 of t, or average of this x1 of t. So this is nothing but, this is 1. So the area under this is 1 into 1, right? So this is going to be equal to 1. So x of j omega is 2 sine omega by 2 by j omega square plus pi delta of omega. Okay, so this is the answer for our first part. So for the second part, we have g of t equal to x of t minus half, correct? So in that case, what we have to do? If we take the Fourier transform, we have, using linearity property, we'll have g of j omega is nothing but x of j omega minus Fourier transform of half. Fourier transform of 1 was 2 pi delta of omega, right? So Fourier transform of half will be half into 2 pi delta of omega, which is nothing but pi delta of omega. So now we can easily find g of j omega by substituting this here. It's nothing but 2 sine omega by 2 by j omega square. So this factor goes away. Okay, so this is what we wanted. Okay, moving on to the next question. Determine the Fourier transform of the following signal. X of t is equal to t sin t by pi t whole square, and determine the numerical value of a, which is nothing but integral minus infinity to infinity t square sin t by pi t whole power 4 dt. So how do we approach this problem? So it will be difficult if we directly try to integrate this and find. Indeed, you will not be able to find it. So first let us start from the simple equation we know, whatever we know. We know that sin wt by pi t has a Fourier transform given by this plus w to minus w to plus w, and this will be x of j omega, right? If it is, okay, let's take some other signal, x1 of t. Okay, this is with omega. Now if we substitute w equal to 1, we get x1 of t equal to sin t by pi t. So this is one part of our signal. So this has the Fourier transform omega x of j omega from -1 to 1. We have this, right? Now if I multiply this x1 of t multiplied by x1 of t, I'll get sin t by pi t whole square, right? I'll get this part of the equation. So its Fourier transform will be nothing but this convolved with x1 of j omega convolved with x1 of j omega. And we'll have a factor of 1 by 2 pi. This we know from the multiplication property, right? Or the modulation property. So this is x1, let's say. So now this is nothing but this 1 over 2 pi into, for square pulses we know how to do it easily, right? When we convolve two square pulses of same width, we'll get a triangular pulse. And what will be the width? So here it is 2, 2. Here it is going to be 4. So it will start from -2 to 2. And what is its height going to be? It will be the area when both of them overlap, right? So the area when both of them overlap is going to be 2. Because it is width is 2 and the height is 1. So this is 2. So this is this signal x2 of t. So this is x2 of j omega, which is nothing but x2 of j omega. This is going to be 2 by 2 pi. This is 1 by pi. That's all. Now what about this t? So we already saw that j minus jt x of t has a Fourier transform dx of j omega by d omega, right? Or if we take this to the other side, tx of t has a Fourier transform j into, because 1 by minus j we can write it as j, dx of j omega by d omega. So we can use this. So t into x2 of t is nothing but j into dx2 of j omega by d omega. Differentiation of this multiplied by j. So this x2 of t is nothing but sin t by pi t whole square. And we have this side j into differentiation of this. What will we get? So this has a linear slope, right? So what is the slope on this side? It is 1 by pi by 2. Just nothing but 1 by 2 pi. Right? And what is the slope here? It is 1 by pi minus 1 by pi, because it is decreasing, divided by 2 minus 1 by 2 pi. So it is going to look like this. It starts from -2. It has a constant value of 1 by 2 pi. And then it drops down and has a constant value up to 2 of minus 1 by 2 pi. So if we call this as x of t, this is x of j omega. So what is my signal? It is actually this way, x of j omega from minus 2, it is 1 by j by 2 pi, and up to 2 it is minus j by 2 pi. This is omega. So I'll write it here. X of j omega is nothing but j by 2 pi for omega less than 0 and minus j by 2 pi for omega greater than 0. Sorry, this is between minus 2, right? Minus 2 and 0, and here 0 less than omega less than 2. So there is also a second part to this question. Determine the numerical value of this. So this is nothing but mod x of t square and dt. So it is nothing but the total energy of the signal. So we can easily find it from the frequency response, right? The frequency domain we can easily find using the Parseval's relation. So I'll open a new page. Yeah, so B part A is equal to integral minus infinity to infinity t square sine t by pi t whole power 4 dt. So this is nothing but integral minus infinity to infinity mod x of t whole square dt. And this is going to be 1 by 2 pi integral minus infinity to infinity mod x of j omega whole square t omega, right? So we know our mod x of j omega whole square. So this is going to be, the j terms will go away, 1 by 4 pi square from minus 2 to plus 2. Because it is only the magnitude, it is going to be same throughout. So what will it come to be? 1 by 2 pi. Integral of this d omega is nothing but the total area under this, which is 4 into, because the width is 4 and height is 1 by 4 pi square. So 4 cancels. We'll get this equal to be 1 by 2 pi cube. So they are asking us to find the numerical value. We can just evaluate this and find. So using calculator, this comes to be 0.01612. Okay. So this is how you approach the problem. You don't straight away go ahead and try to find the Fourier transform using the analysis equation. You have to use the properties and the basic Fourier transform pairs to arrive at the solution. Okay. Moving on to the next question. Consider a signal x of t with Fourier transform x of j omega. Okay. Suppose we are given the following facts. The first fact is x of t is real and non-negative. And the Fourier inverse of 1 plus j omega x of j omega is nothing but a e power minus 2t u of t, where a is independent of t. Basically a is constant. And we have integral minus infinity to infinity mod x of j omega whole square d omega equal to 2 pi. Or if we bring the 1 by 2 pi this side, the total energy of the signal is 1. So they are asking us to determine the closed form expression for x of t. So let us go one by one and see what we get. So the first condition given is x of t is real and non-negative. For now we can't say much about it. So let us move on to the second condition. So the inverse Fourier transform of 1 plus j omega x of j omega is a e power minus 2t u of t. So a e power minus 2t u of t as a Fourier transform of 1 plus j omega into x of j omega. But we can actually derive the Fourier transform of this, right? So this is nothing but a by, so e power minus a t u of t. Fourier transform is 1 by a plus j omega. So here there is just a constant, right? So it is going to be a by 2 plus j omega. So these both are going to be equal. So 1 plus j omega into x of j omega is equal to a by 2 plus j omega. So x of j omega is nothing but a by 1 plus j omega into 2 plus j omega. Now let us try to get the inverse Fourier transform. For that we have to split the denominator. So what we do, we take 1 plus j omega, 2 plus j omega. So we need to get 1 at the top when we combine them. So how do we do it? If we put 1, 1 here, then 2 plus j omega minus 1 plus j omega, we get the minus j omega terms go away and 2 minus 1 becomes 1. So this is a good coefficient. This is the coefficient we wanted. So now if we take the inverse Fourier transform of this, what will we get? Inverse Fourier transform is nothing but x of t is equal to a into e power minus t u of t minus e power minus 2t u of t. So this is my x of t. So now let us use the condition x of t is real and non-negative. So what can we say about a? So a should be real because these are real and a also should be real. So what can we say about the sign of a? So let's observe what happens to e power minus t. So this starts from 1 u of t and e power minus 2t u of t. So e power minus 2t is going to fall faster than e power minus t. So this term is positive, right? So this is positive always. It is 0, then it becomes positive. So a also should be positive. So it is a positive real number. Now let us use the third condition. Integral minus infinity to infinity x of j omega d omega mod square is equal to 2 pi. So this 1 by 2 pi is equal to 1. So this is nothing but minus infinity to infinity x of t mod square dt, right? Parseval's relation. So what we have? So this is nothing but a square, right? Integral minus infinity to infinity e power minus t. Since u of t is there, we can take it from 0 to infinity minus e power minus 2t whole square dt. So a square, this side we have 1, integral 0 to infinity e power minus t whole square will be e power minus 2t plus e power minus 4t minus 2 e power minus 3t into dt. So taking integral of this, what will we get? E power minus 2t by minus 2 plus e power minus 4t by minus 4 minus 2 e power minus 3t by minus 3, and the limits is from 0 to infinity. So applying infinity, all becomes 0. So then we'll get minus of this 0 term, all will become 1. So a square into this minus term is there, so it will be 1 by 2 plus 1 by 4 minus 1 by 2 by 3. So the LCM is 12. So a square into 6 plus 3 minus 2 into 4, 8 by 12. So this is a square into 1 by 12 is equal to 1. So a square is equal to 12. A is equal to plus or minus root 12. But minus we are neglecting and we will get only a equal to root 12. Why? Because a is real and positive. So what is our x of t? X of t is given here. So our x of t is root 12 into e power minus t minus e power minus 2t u of t. So this is our x of t. Okay. So now let us move on to the next question. Consider a causal LTI system with frequency response. H of j omega is equal to 1 by j omega plus 3. For a particular input x of t, this system is observed to produce the output y of t is equal to e power minus 3t u of t minus e power minus 4t u of t. Determine x of t. So the approach we'll take is we'll find y of j omega from this. And then we have h of j omega and y of j omega. We can find x of j omega. And then we'll take the inverse Fourier transform to find x of t. So that is simpler rather than finding h of t from h of j omega and doing like we need to do inverse convolution kind of. So that is really difficult. So this is a easy approach. So my y of j omega is nothing but 1 by 3 plus j omega minus 1 by 4 plus j omega. So adding them we get 1 by 3 plus j omega into 4 plus j omega. So my x of j omega is nothing but y of j omega by h of j omega. So which is nothing but 1 by 3 plus j omega into 4 plus j omega by 1 by, this is 3 plus j omega. So this cancels, I get 1 by 4 plus j omega. So now I can take inverse Fourier transform. So x of t I can easily get it as e power minus 4t u of t. So you saw how quickly I solved it. I mean, needn't even consider the convolution. Okay, moving on. Let us now see some gate questions. So the Fourier transform of x of j omega of the signal x of t is equal to t by 1 plus t square the whole square is. So we need to find the Fourier transform of this signal. So if I observe this signal t by 1 plus t square whole square, it is nothing but 1 by 1 plus t square. If I take derivative d by dt of this, I will get minus 1 by 1 plus t square whole square into 2t, differentiation of this. So this I'll get as minus 2t by 1 plus t square in whole square. So if I call this as x1 of t, so this is dx1 of t by dt, and my x of t is nothing but minus 1 by 2, right? Minus 1 by 2 dx1 of t by dt. So if I able to find the Fourier transform of x1 of t, then I can easily find the Fourier transform of x of t. So again, this 1 by 1 plus t square is something of the similar form we solved, right? So if I go back, here the first question. So we had this relation. Let me take it here. Yeah. So we got this from the first equation. So now we also know the duality condition, right? So for this, if we were to write the duality, what will it be? 2a by a square plus t square will have the Fourier transform 2 pi into x of minus omega, right? Minus t. So 2 pi e power minus a mod of minus omega. But minus omega is same as, like mod of minus omega is same as mod omega. So this is equal to 2 pi e power minus a mod omega. So if I observe this and this, right, this and this, I can take 2 to the other side, like basically dividing by 2, right? So I'll get pi e power minus a mod omega. So now if I use a equal to 1, then this 1 by 1 plus t square has a Fourier transform pi e power minus mod omega. So x1 of j omega is nothing but pi e power minus mod omega. And using this, x of j omega is nothing but minus half into j omega into x1 of j omega, right? So then using this here, I will get minus half, right, into j omega, x1 of j omega is pi e power minus mod omega. So this is minus j by 2 omega pi e power minus mod omega. So let us try to compare. So it is of the form pi by 2j, right? So if I convert to that form, minus j is nothing but 1 by j. So pi by 2j into omega e power minus mod omega. So which is option A, right? So you can see pi by 2j omega e power minus mod omega. So option A is the right answer. So here also you have used the properties and the basic Fourier transform pairs. Otherwise it is nearly impossible to find the Fourier transform of this function directly using the analysis equation. Okay, moving on. If x of omega is the Fourier transform of x of t shown below, okay, the value of integral minus infinity to infinity mod x of omega whole square d omega rounded off to 2 decimal places is. Okay, so this one also is again using Parseval's theorem. We should approach this problem. So integral minus infinity to infinity mod x of omega, j omega, everything are same only. So d omega is equal to 2 pi integral minus infinity to infinity x of t mod x of t whole square dt. So let us try to find the area of mod x of t whole square dt. So how will it look like? So let us go part-wise. I'll call it region 1, region 2, region 3 and region 4. So region 1. What is my equation? So it is t minus 1. So x of t is t minus 1. So my integral minus infinity to infinity t minus 1 whole square dt is nothing but t square minus 2t plus 1 into dt. So t cube by 3 minus t square plus t. Again, sorry, this is not minus infinity to infinity. It is minus 1 to 0. So minus 1 to 0. At 0, everything is 0, right? So minus 1 is minus of minus 1 by t minus 1 plus 1. So this is minus 1. Again, this is minus 1. So this is going to be minus of 1 by 3 minus 2, which is minus 5 by 3, right? Minus of minus 5 by 3. So this is 5 by 3. So now coming to region 2. So region 2, what is my x of t? You can see its slope is now 2, right? So my x of t is 2t plus 1. So 2t plus 1, right? At 0 it is 1 and at 1 it is 3. So now if I integrate it from 0 to 1, 2t plus 1 whole square dt is nothing but integral 0 to 1, 4t square plus 4t plus 1 into dt. So which is nothing but 4t cube by 3 plus 2t square plus t from 0 to 1. So only one terms will exist. So 4 by 3 plus 2 plus 1. So this is 4 by 3 plus 3, 9, 13 by 3. Again, just to check. So again, this is t cube, right? So this will be minus 1 by 3. So it is minus 1 by 3 minus 2, which will give me... Oh, sorry guys. I think this equation is t plus 1, correct? Because at t equal to 0, sorry, at t equal to minus 1, it is 0. At t equal to 0, it is plus 1. So I have to change this. This is t plus 1 whole square. So this will be plus 2t. So plus, here plus 1 minus 1. So this will just be plus 1 by 3. Okay. So now these two are the thing. So, and my region 3 and region 4 is going to be equivalent to region 2 and region 1. So my total area, integral minus infinity to infinity mod x of t whole square dt is nothing but 2 into 1 by 3 plus 13 by 3, which is nothing but 28 by 3. 14 into 2, 28 by 3. But we were asked to find this integral. So which is nothing but this multiplied by 2 pi. So we shouldn't miss that factor. So minus infinity to infinity x of j omega mod square d omega is nothing but 2 pi into 28 by 3. So this is going to be 56 pi by 3. So you should be careful not to make these mistakes and also to take care of this 2 pi factor. And we can very well evaluate this, which is 56 pi by 3, which is nothing but 58.64. Okay, so this is the answer. 58.64. So moving on to the next question. Let x of t gives a Fourier transform x of j omega be the Fourier transform pair. Okay. The Fourier transform of the signal x of phi t minus 3 in terms of x of j omega. Right? Okay. So we have x of t is nothing but x of j omega. So first we'll do the shifting operation. So x of t minus 3 will give me e power minus j omega into 3 x of j omega, right? So which is nothing but e power minus j3 omega x of j omega. And now let us do the scaling operation. So phi t minus 3. So scaling we know, right? So I'll write both the things here. So for shifting it is nothing but x of j omega multiplied by e power minus j omega t naught x of j omega. And scaling we have 1 by mod a x of j omega by a. Okay. So all these are Fourier transform. Okay, so now I am doing the scaling. I'll get 1 by phi, mod phi is anyway phi, e power minus j3 omega by phi, right? And x of j omega by phi. So now if I simplify this, this is 1 by phi e power j 3 by phi omega x of j omega by phi. So this is my answer. So here also there is subtle variation. You should not do the scaling first. If you do the scaling first, then you have to take care of that during shifting, right? I'll maybe demonstrate that as well. So this is shifting first. Shifting first, scaling second. So let us now do the other way. Scaling first, shifting second. Okay. So again here x of t gives x of j omega. So I do the scaling first. X of phi t gives me 1 by phi x of j omega by phi. So this is straightforward. Now if I have to do the shifting, I have to do phi into t minus 3 by 5. Then only I will get phi t minus 3 finally, right? That is what being asked. So I need to shift by 3 by 5 now. So then what will happen? I'll get e power minus j 3 by 5 omega by 5 x of j omega by 5. So this again it is same. So this side will evaluate to x of phi t minus 3. So you can see both sides you get the same answer. Sorry, here I missed the minus sign, which is being carried over from the previous step. So my answer is 1 by phi e power minus j 3 omega by phi x of j omega by phi, which is option A. Okay. So moving on, this is our last question for the day. The value of the integral, so I'll write the integral here, 12 cos 2 pi t sine of 4 pi t by 4 pi t dt. So if you observe, this is nothing but the average of this signal. So if you are somehow able to find the Fourier transform of x of j omega, and this will be nothing but x of 0. So let us try to do it that way. So for that I will first take sine of 4 pi t by 4 pi t. So what is this Fourier transform? Here w is 4 pi and there is a factor of 1 by 4. So I will get 4 pi minus 4 pi and this is 1 by 4. So this will be the Fourier transform of this signal. Agreed? Because sine wt by pi t will give me the Fourier transform w to minus w with value 1. Here there is 1 by 4 factor and w is 4 pi. Okay. So next my cos 2 pi t. So this is a periodic signal. So what will be its Fourier transform? It will just be an impulse at 2 pi and minus 2 pi. And what will be the value of impulses? It will be 1 by 2. Right? Because it is cos 2 pi t is 1 by 2 e power j 2 pi t and 1 by 2 e power minus j 2 pi t. Okay. Now if I multiply these signals, it is like a modulation. So I will get convolution in this, in the frequency domain, right? So I will get 1 by 2 pi into convolution of this with this, correct? So if I write this as two separate signals, then my convolution will be just addition of convolution with this and convolution with this, right? So let me demonstrate that. So convolution. So I'll take these two signals. So this convolution is equal to convolution of this plus convolution of this, right? Correct? Agree? Okay. Now let us try to find the convolution of each. So convolution with the impulse is very easy. So this will be, since it is from minus 2 pi, it will have an extension of 4 pi this side. So from minus 6 pi to 2 pi, and what is the value? It is 1 by 4 into 1 by 2. It is 1 by 8 plus, on this side what do I have? It starts from center is shifted to 2 pi. So it will go up to 6 pi and this side it will be minus 2 pi. And again here it is 1 by 8. Now if I add this, there will be the region of overlap from minus 2 pi to 2 pi. So it will be minus 6 pi, minus 2 pi, 2 pi, 6 pi. So here it will be like this. So here it will be 1 by 8, here it will be 1 by 4. Again here 1 by 8. Now what I need to do? And also we forgot one thing, which is nothing but the 2 pi factor, right, for cos. So cos omega naught t is not 1 by 2, it is actually pi delta of omega minus omega naught plus delta of omega plus omega naught. So this 2 pi factor we forgot. So if we modify that, it will just be pi and pi. So this is going to be pi, pi. This is 1 by 4 pi. This is also 1 by 4 pi. And this is going to be 1 by 2 pi or pi by 2. This is pi by 4 actually. So these are pi by 4. So now my x of j omega is actually this into 1 by 2 pi, right? So my x of j omega is nothing but 6 pi 2 pi minus 2 pi minus 6 pi, right? It's nothing but 1 by 2 pi x prime of j omega. So this will be 1 by 4 and these will be 1 by 8. So then my integral I can now find. Again 12 is there, right? So this into 12. This will be 3, 1.5 or 1, 3 by 2, 3 by 2. So my integral minus infinity to infinity, 12 cos 2 pi t sine 4 pi t by 4 pi t dt is nothing but this x of 0, right? And that is equal to this point 3. So the value of the integral is 3. So that is our answer. So here also we should be careful to remember for periodic signal there is actually a factor of 2 pi. If we miss that, then we would have got 3 by 2 pi and our answer would have gone wrong. So there also, like, even though we are using the properties, we should be careful enough not to make a mistake. And sometimes it is normal to make a mistake when we are doing it in very, very quickly. So it is always a good practice to check the steps once before moving on to the next question. Okay. That's it for today, guys. Hope you have learned more about Fourier transform. So let us connect again in the next video. Until then, stay tuned. Bye. Take care.